He was my friend. He was a rapper. And now he is missing. Where is rapper Karan? We're gonna be late for Pilates. What is it?
Rapper Karan's not gonna be here, sir.
What do you mean?
It's like the limit of X as it approaches A. It'll always get closer, but it'll never reach.
Well,
at first I didn't know what Abdullah was talking about, and then I learned about limits myself. A limit is as an X approaches a constant, it'll get closer and closer to the limit, but it will never reach the limit. And to find the limit, you have to know how to solve limits. So first we'll do this easy limit problem with 5x squared minus 8x minus 13 over x squared minus 5, and find the limit as x approaches 3. Now this is a simple limit problem where you just have to substitute in 3 and you get 8 over 4, which is 2. Now the next limit problem isn't as easy. The equation is 3x squared minus x minus 10 over x squared minus 4. And here you can't directly sub, as the denominator would equal 0 and you can't have the denominator equal 0. So you have to factor the top and the bottom and split them up and then cancel whichever ones cancel on the top and the bottom, which gives you another equation. The limit of 3x plus 5 over x plus 2 as x approaches 2. Now you can directly solve, as there no longer is the problem of having a 0 in the denominator, and you get the limit as 11 over 4. And to go back to what I said in the beginning to better illustrate what I mean, we'll look at this problem. The limit is x squared plus 4x minus 12 over x squared minus 2x as x approaches 2. Now instead of doing what we did before by factoring, I decided to make a table to show you how, as you get the numbers closer and closer to x equals 2, the f of x gets closer and closer to 4. So because of this, you can safely assume that the limit is 4. But as you get closer and closer by x, you will never actually reach 4. You'll be just a tad bit off every time. Therefore, you'll never actually reach 4. That's what the limit.
now, thankfully, the air company gave us the equation of the plane. Now we can just use that equation to find the position and the speed that he went, and go find rapper Karan. Yeah!
So thankfully, the aircraft company gave us the position function of where the plane is going to be. So the equation they give us was 100t minus 10t, and that's the position function, and t is time in hours, and the position is how far in miles off the coast of New York the plane is. So to find this position, first we gotta find where the velocity is 0. And to do this, you gotta take the derivative of the position function to get the velocity. So after you take the derivative, you get 100 minus 10t. And then to find the velocity, which is 0, you make the equation equal to 0, and that will give you the time at which the velocity is 0. And that is t equals 10 hours, meaning that at 10 hours, the plane's velocity was at 0. Now we can take the 10 and plug it back into the original position function to find out exactly how many miles off the coast of New York the plane is. And when we do that, 100 times 10 minus 5, 10 squared, we get 500 miles off the coast of New York. Now we can use this to go find where Karan's plane is and save him.
Golly me, there isn't. Now, let's just go to the ocean people and figure out how much water we need to take out to get this plane. Yeah!
Tomorrow.
So I just talked to the water people. They told me exactly where the plane is and how much water there is between there. Now we just gotta use the integral formula to find out exactly how much water is under the surface. Yeah!
So the ocean people told us that the plane is between 100 and 500. They also gave us the equation 10x squared minus 6s x plus 3. Now we can use this to find out how much water there is between 100 and 500 to know how big of a vacuum we need to get to suck up all that water. To do this, first we need to integrate 10x squared minus 6x plus 3. And for all three of these, we can use the power rule and get 10x to the third over 3 minus 6x squared minus 2 plus 3x. And now that we do that, we can start to input 500 and 100. Now, when we do that, we input 10, 500 cubed over 3 minus 3 500 squared plus 3 multiplied by 500. That's all one section. And then you multiply that by the 100 section, so it's top minus bottom. So it would go 10 multiplied by 100 cubed divided by 3 minus 3 multiplied by 100 cubed plus 300 multiplied by 100. And that's another section. Now what you do is you simplify between these two sections and you get a single number in each section, which will make it much easier to solve later. So what we do is we take 41,666,666 minus 750,000 plus 1,500, and we get 40,918,166. And then we do the 100, which we have 3,333,333 minus 30,000 plus 300. And when we do that, we get 3,303,633. Now when we subtract these two numbers together, we get 37,614,533 gallons of water. We're going to need a really big vacuum to get all that water. What we're gonna do.
Now that we know how much water there is, we just need a big enough vacuum to suck it all up. How are we gonna do this, Abdallah? No! Can't you give me a good answer? No!
6 hours later.
I'm sorry I hit you. I figured out a way to get the water, okay? We can use the washer method. Figure out what the size of the vacuum needs to be. Yeah! Oh, let's go. You want some ice cream?
So after that whole ordeal, I decided to use the disc and washer method to try to find how big this vacuum has to be. Now the store that we went to said that the vacuums they sell only come in y equals g of x equals x and f of x equals square root of x. And for some reason, this is how this vacuum place does it. So it makes it very hard for us to actually find the volume. To do that, we gotta use the disc or washer method. And to do that, we do 0 to 1 pi because we're revolving it around the y-axis, and we do f of x squared minus 0 to 1 pi g of x squared dx for both. Now in the next one, we make it simpler so we can actually solve the problem later without having too much trouble, and we bring out the pi in front, we do all the arithmetic, and that's the equation we get. And then in the end, now we do the power rule and we integrate the whole formula, and we do it from 0 to 1. The pi is still on the outside. Now since the bottom number is 0, it's not really necessary to do it as it will always end up being 0. So I only did 1. So after I multiplied both sides by just 1 and then pi, we get the equation pi 1 squared over 2 minus pi 1/3 cubed over 3, and then that gives us pi over 2 minus pi over 3, which equals pi over 6. Now, as you may have noticed, that's not big enough of a vacuum for us to actually suck up all the water that we need. But this is just because we did the dimensions from 0 to 1. But this vacuum place sells much bigger vacuums. Me and Abdallah just have to do a lot of searching to find a vacuum that's big enough and do this washer disc method many times to make sure that we have a vacuum that's big enough for us to use.
Now that we have all the calculus down, let's go and suck up all that water.
1 eternity later.
Thanks, Repicron. I don't know what I could have done without you. I had to eat all the people in there. It's alright, Repicron. I'm just glad that you're safe. So what'd you do all that time you were down there alone? I made a sick feat that nobody can defeat. And while I'm doing derivatives, calculus will be my initiative.
Name's Repicron and I'm here to teach you math. These skills you will be able to pass. You need calculus to make it through your day. Just look at SK, use calc to come and save the day. Matter where I be, he did it with glee. Use derivatives to come and find me. From limits to positional to integral, that's me. Now everyday Quran is slang. You best be going before he come lame. You sick beats all to your brain, so come and escape your hand. Now saying my name, Rapper Quran, Rapper Quran, Rapper Quran. Now come on with me and say it with glee, Rapper Quran. rapper crime. Now with my skills, it's no mystery that I shall be slain and will be with glee. Now SK did his job, now it's my turn. Now let's go get a cup of rapper crime. That's it, I'm outie.